right. My name is Engineer Chum Keji Ocan. I am a faculty member of Cebu Institute of Technology University here in the Philippines. And I'm going to present my research topic titled Dynamics of Task Load and Job Satisfaction Levels of Engineering Faculty in Selected Engineering Schools, a Fuzzy Cognitive Mapping Approach. In the field of research, the Fuzzy Cognitive Map is a promising tool that is currently rising right now, being utilized by several studies in social sciences. The reason why we are interested with studying with task load and job satisfaction is because there are several gaps on the study of these variables. We have a gap on the utilization of the NASA TLX task load questionnaire components being used to measure task load. There are also gaps with regards to the use of fuzzy cognitive map to determine causal relationship between these variables. And also on the improvement of organizational performance, less is conducted with regards to how to improve the competencies of our engineering faculty, which shapes the future of our engineering students and future engineers. The reason why we have utilized fuzzy cognitive map, because again, it allows simulation across different behaviors of a system, because we view job satisfaction and task load as a complex system. By using fuzzy cognitive map, we're able to map out the interrelationships across these variables and understand the behavior or changes across one elements of the system. The objective of this study is for us to profile the different engineering faculty in terms of the program, because we have several engineering specializations or engineering program. The average load, or the average teaching load per semester, the age, years of experience, and the number of students. Second is for us to describe task load and job satisfaction levels among these engineering faculty. And last is to explore causal relationship of the task load and job satisfaction of our engineering faculty. The research has utilized survey questionnaires, descriptive statistics, Kruskal-Wallis and ANOVA statistical tools to determine differences on the mean responses, as well as regression to determine linear relationship across different variables used, and fuzzy cognitive map to identify causal relationship and changes of task load and job satisfaction components of engineering faculty. Based on the results of demographics across the 3 different selected engineering schools, the load per semester, age, years of experience, and number of students differ across different engineering specializations, such as industrial engineering, chemical engineering, mechanical engineering, electrical engineering, communications engineering, and civil engineering. The same is also true with regards to the load per semester, the age, years of experience, and number of students across different engineering schools. So they are technically different. Based on the analysis on variance at Kruskal-Wallis, the load per semester is significantly different among universities. The mean age, or the average age, is also different across different engineering schools, but the years of experience has no significant difference across different universities, and the number of students is significantly different among universities. It is also found out that the task load index is significantly different among universities. This means that each of the engineering faculty, or all of the engineering faculty members, have different mental demand, physical demand, temporal demand, performance, effort, and frustration based on the task load index by NASA. Also, by utilizing regression, we have found out that temporal demand, which is the time pressure of our faculty members, are being dictated by the class size, meaning the higher the number of students in a class, the engineering faculty would feel pressure in terms of time. So that's one of the findings in the regression. Okay, the job satisfaction levels, in terms of job satisfaction level, is also significantly different among universities. Across different groups or elements or variables of the job satisfaction level, such as immediate head, colleagues, work environment, nature of job, compensation, benefits, and work-life balance. And based on the regression analysis, immediate head satisfaction is correlated with load per semester. This means that the higher the load of a faculty member, the more they are satisfied with their immediate head. But it has a weak positive relationship, suggesting that more faculty load would indicate higher immediate head satisfaction. Also, it is also found out, based on the relationship between the task load and the job satisfaction, that physical demand is correlated with immediate head satisfaction, suggesting that if faculty is physically loaded, it would indicate dissatisfaction to immediate head. Also, temporal demand and frustration is correlated with colleague satisfaction, suggesting that if faculty is pressured on time and annoyed in terms of frustration, it would indicate dissatisfaction with colleagues. Another interesting finding is immediate head satisfaction is correlated with physical demand, suggesting that if faculty is satisfied with the immediate head, it would indicate a decrease in physical demand, the less physically strained they are in their work. Also, colleague and work environment satisfaction is correlated with temporal demand. This means that if the faculty is satisfied with colleagues and the work environment, it may indicate decrease in time pressure. For the last objective, which is the fuzzy cognitive mapping, the derived from the survey responses as well and regression standard coefficient, we're able to map out the relationships across different variables of the task load and of the task load and the job satisfaction levels by using this map, by looking at this map. Also, since the fuzzy cognitive map is used to simulate decisions, we're able to have two states of the scenario. We have the activated state or the decreased state, meaning we decrease all the job satisfaction levels and the task load and see what happens to the system. It turns out that the compensation is not dictated across different elements based on the deactivated states. However, on the activated state, if we increase the job satisfaction and increase the task load level, it shows several causal relationship across these elements. The levels of change is also dictated by the standard formula to the level of change, which is denoted by C. So this is where the change of the values are derived. So based on the findings, the researchers have come up with the following recommendation. Number one, to decrease the overall workload based on the results, the ideal class size of our engineering faculty students should be between 20 and 24 students only. Also, for office assistants, we have found out that we need to decrease the physical and mental load of our faculty. Office assistants are also recommended across different departments. For the increase of colleague and immediate head satisfaction, collaborative work is also recommended. And for the time pressure or the temporal load, which is a significant factor for task load of our engineering faculty, it is recommended to draft a policy or to come up with a policy for flexible scheduling. And lastly, for workload and job satisfaction improvement, to continuously assess job satisfaction and workload for tailored HR interventions, we should come up with, the university, specifically for engineering faculty, feedback mechanism must be put in place. So once again, this is Chum Keji Ocan. I'm now ready for your questions and answers. Again, my research title is Dynamics of Task Load and Job Satisfaction Levels of Engineering Faculty in Selected Engineering Schools, a fuzzy cognitive mapping approach. I'm from the Philippines. Anyone from the audience? Do you have any questions?